Hello Data Nerd, what's up? In this session, we are going to study an important Power BI DAX function which is called filter function. To a great extent, this filter function talks about itself. It says that, hello, I'm a filter function and I filter a table. But what does it return and how does it filter a table? That's something that we need to study. So let's get started. So the very first question that comes into picture is, how does filter function work? How does it actually filter a table? To understand that, let's first see the formula of the filter table. The formula has two arguments. The first argument is table. So first we write the filter function and the first argument it accepts is table. This table is nothing but it is asking to give the name of the table that you want to filter. And the second argument is filter expression. Now, what filter are you trying to apply on this table? So these are the two simple arguments that filter function asks before it filters a table, right? Now, for example, I have this auto sales data. This is a physical table stored in my data set, in my semantic model. If I just go to the table view, if I open this auto sales data, I can see the table, right? I have order number, I have quantity ordered, I have status, right? Now, I want to apply a filter on this table. I have a lot of status here. I have cancelled orders, disputed orders, in process, on hold, resolved and shipped. But out of all this status, I just want to see the orders which are shipped. So I want to extract a part of this table with rows having shipped at status. That's what my requirement is. What am I supposed to do? I'm just supposed to write the filter function and then I'm supposed to give the name of the table, which in my case is auto sales data. And then what is the column name? Column name is status, which should be equal to shipped. That's simple it is, right? So first I just wrote the filter function, then I gave in the argument of table, I just gave the name of the physical table that is already stored in the semantic model, which is auto sales data. And then in the place of the filter expression, I wrote the column name and what I want it to equivalent to. So I want this data should be equal to shipped. And then I want to filter those rows, right? So that was my requirement and I gave that. Simple. Now there's an important part I want you to remember. This table that we're talking about, this table can be a physical table which is already stored in the dataset. In my case, I already have a dataset called auto sales data. This is a table which I have imported from a CSV. So this is already stored in my semantic model. Now this table can be one such physical table, or you can also create an on-fly table, which might not be present in this data set in your semantic model, but on-fly you'll create a table and then you'll apply a filter on that table. You'll understand it better when you write the formula, but for now just understand that this filter function accepts both kinds of table. It accepts the physical table which is already available in your Power BI. It also accepts an on-fly table which you just create right there, and then in filter expression, you write the filter that you want to provide. It works that way as well. My next example tells that. So as it already says, the table to be filtered, the table that you want to filter can be a physical table, which is already stored in your semantic model, or it can be an on-fly table. So it's possible that this table is not available in your dataset, but you calculate that table, you create that table, and then you apply the filter. In my next example, I have written that filter. Now, you see this values till customer name. What am I doing? I'm creating a table, right? How am I creating? I'm using values. Now, when you use values, you can either give a table name or a column name, and then it creates just one column table. So in my case, I have given values, and from auto sales data, I have given one column name. So I've just given customer name. What will this do? This will create a one column table and the column would be customer name. So out of auto sales data, it will take all the unique values of customer name. So now my imaginary table is ready. Power BI has already created an on-fly table using this one column. That table has only one column, which is customer name, unique customer name. Remember, when you use values and when you give the column name with which you want to create a table, it always creates the column name. It always creates the table with the unique values in it. Okay, it removes all the duplicates. So the first argument, which was of table, is ready, right? Now, you did not have this table already. You did not have a table which only had one column of customer name. You did not have it, right? But you created with the help of values. And filter accepts those kinds of table as well. Filter accepts on-fly table as well. So this is what on-fly table is, that an imaginary table was created with the help of values. You will not be able to see this in your semantic model, but it has already created in the backend. Now, upon this on-fly table which we have created, which just has one column, we are applying the filter that I just want to see those customer names whose average sales is greater than 2000. So this is what we mean when we say that filter also accepts on-fly table. You'll understand this in detail when we actually write the formula. So now we have established how filter works. The question now comes that what does filter return? Right? Does it return a scalar value? Does it return a text or a table? So the answer is filter always returns a table. It does not return a scalar value. It does not return a text. It always returns a table. Okay, so filter applies the filter on a table and in return it again gives you a table. Remember that. So in both these examples that I've given you, my return will be a table. In this case, a new table will be created, a new physical table will be created where I'll have only those rows where status is equal to shipped. In this case, again, a new table will be created with only one column in it where I'll have only those customer names whose average sales are greater than 2000. Now, let's just see this Microsoft official page where they have explained this filter function. It's always a good idea to read these things, okay? Now, this is filter. It says that returns a table that represents a subset of another table or expression. Let's understand what does it mean. Of course, this is clear that it returns a table. We just understood that filter always returns a table that represents a subset of another table or expression. Now, what does it mean? The table which you are getting in return is a subset. Is a subset means is a part of a bigger table. So if you remember, I gave you the example that I already have this bigger table auto sales data. This is the bigger table, right? Now I just want to extract a part of it, a subset of it, only with those rows where status is equal to shipped, right? So the result which I'll get after writing the filter formula, that will be a subset of this bigger table. That will be a part of this bigger table, correct? So that's what it's trying to tell, that it returns a table that represents a subset of another table or expression. If you remember, I also told you that filter table also accepts on-fly table, right? It does not necessarily have to be a physical table, and that's what we did here. We wrote an expression, that expression resulted in a table, and then we applied a filter on that table, correct? So that's what it's trying to say, that it's a subset of another table, means another physical table or expression, or the on-fly table that you create with the help of the expression. On that also you can apply the filter, and then you can extract the subset of that table as well. And then it talks about the syntax, which is of course the first argument is table, and then we have filter. We already have studied that. Then comes parameters. You have two arguments, one is table, one is filter. The first argument, which is table, this is nothing but the table to be filtered. Let me just zoom it out. Yeah. The first argument, which is the table to be filtered, it says that the table can also be an expression that results in a table. It's talking about that on-fly table that we just discussed. It says that the table can be physical, it can be already available in your semantic model, or you can calculate right there and then you can apply filter on that table. Okay, so we're done with this line. Then comes filter. Now it says a Boolean expression that is to be evaluated for each row of the table. Now this is very important. The another argument that we have, which is nothing but filter expression. Now remember, this check happens, right? Whether status is equal to shipped or not. The result of this filter expression should always come into Boolean expression, means true or false. And then the next part was this Boolean expression to be evaluated for each row of the table. So how will this work? Filter will go into this table, which is my auto sales data, and then it will go into the status, right? It will check each row. It will check that, okay, first row, the order is equal, the status is equal to shipped, true, row considered. Second row, status is equal to shipped, true, row considered. Again, it will check like that to the all rows, and it will come down somewhere like, come on, yeah. So now, then it will check this row, that status is equal to on hold, false, row not considered. Again, it will come status is equal to cancelled, false, row not considered. And then these rows will not be considered in the final result that we are getting. Understood? That's why filter function is an iterator function. Remember, this is very important. Filter function is an iterator function because it iterates over each row. It checks each row, and the filter function has to return true or false. The true values will be considered in the row and the false values will be ignored. Now, this is what it meant when it said a Boolean expression that is to be evaluated for each row of the table. Understood? The second argument, which is filter expression, that has to give the result of true, false. True will be considered and false will be ignored. That's it. And then comes return value. What does it return? It returns a table, and then it says a table containing only the filtered rows. That's it. So it returns a table for which the Boolean expression was true, right? So just give it a read to these articles. It's always very helpful. Now we're done with the theoretical part. Let's write the formula. Now we already know that filter returns a table. So when you write this formula, you always have to choose new table. You're not going to write a new measure or new column. You will choose a new table. So just go to modeling and you'll choose new table, right? And then we'll start. So my table name would be shipped order. What is the formula? Filter, right? It asks for the table. So it's asking that which table do you want to filter? I want to filter my auto sales data. Done. I have given that first argument, comma. Then filter expression. What is that filter that you want to apply? I want to apply a filter which has, status, right? Status is equal to, it should be shipped. That's it. Now, auto sales data, the first argument done. This table I want to filter. In that, I have a column called status. I just want to create the table which should have only this status, which is shipped. Now, commit it. Let's check. Do we have that table created? Yes, we have. You see here, it says shipped order. We have all the columns because we have not given any restriction that we want only one column or two columns. So it has all the columns. Let's go to the table view and let's check. Shipped order, right? Now, if you remember, in my auto sales data, the original table, it had all the status. Okay, now the new table which I have created, it should have only shipped as the status. Let's check. And yes, it only has shipped as the status because that's what the filter we have applied, right? We did not want to see all the status. We just wanted to see the shipped status, and that's why we have all rows have only just shipped status. Now this new table that we have created called shipped order, this is nothing but a subset of this major table. Now in this formula, a physical table was filtered, right? Auto sales data, which is already available in my semantic model, and I filtered that. But what if I want to create an on-fly table right there and then I want to filter that? How do we do that? Imagine I'll just go to my major table, the main table, right? And then we have something called customer name. So these are the customer names. I want to first create a table which should only have this column. In that, I do not want to see all the columns because I don't need it. Now, then I want to apply a filter that the sales column, you must have a sales column, right? The sales column should be greater than 2000. I just want to have one column table which should have only those names where sales is greater than 2000, right? So let's create it. So first of all, understand. So the requirement that we have should only have one column. And what is that column? The column is customer name. But currently in our main table, we have all the columns present, right? So what are we supposed to do first? First, we are supposed to calculate an on-fly table which should only have one column in it, right? That we are supposed to do with the values. So first we'll create a table which will have only one column in it, and then we'll apply a filter and all those customer names will be removed whose sales are less than 2000. Let's do that. So we'll go to modeling and we'll again select the new table. Click on this and then maybe average sales greater than 2K. Yeah, that will be the name of my table. Now, first, what am I supposed to do? I don't want to use the original table. I want to create an on-fly table. So I'll use values. Now remember, values asks for a table name or a column name. It either asks for a table name or a column name, right? Now, read this. When a column name is given, returns a single column table of unique values. So if you are going to give a column name, which I'm going to give right now, I'm going to give a column name of customer name. What does it do? It returns a single column table. So you'll have just one column in that table. It will return a table for sure, but it will have only one column which you have given, right? Of unique values. In your major data set, if the values of that column is repeating in different rows, those duplicate values will be removed and the table will have one column with unique values. That's what it does when you give it a column name. Okay. Then second is when a table name is given, returns a table with the same columns. So if I just give auto sales data, which is my major table name right now, it will just return the table with the same columns. Whatever columns you have given, it will return with all the columns. But right now I do not want all the columns, and again in on-fly table, extracting all the columns is just redundant. You don't want to extract all the columns because you don't need it. If you remember, in SQL also, we studied that select star from table. That is not a very optimized query. You don't want to see all the columns and all the rows every time, right? So it's always a good idea to optimize it by restricting it with the name of the columns or the rows you want. So that's what we're trying to do here. So what do we want to do? We just want to have one column, which is customer name. The on-fly table will have only one column table with this, and I'm going to close it. So my on-fly table is ready, correct? I forgot to use filter, so I have to use filter first. The first argument is ready, which is table, right? Now, comma, then is filter expression. So what do we want? We want I already have this average sales created. I already created this measure. This is nothing, just a simple measure. You write here average sales should be greater than 2000. Okay, so understand what is happening here. What is the first argument of the filter? Table, right? Which we are creating here. This table was not available, so we are creating an on-fly table, and then on that table, so the customer column that we have right now in this table, we are only wanting to see those rows where average sales is greater than 2000. Okay, let's see what happens. Comment. A new table should be created, which is average sales greater than 2K. Close everything, expand it. And now you see, we just have one column because that's what we gave, right? That's what we told. So let's go to table view. The new table which we have created only has one column name, which is customer name. And then who are these customers? These customers are those customers whose average sales is greater than 2000. Now, you just want to check whether they have 2000, the sales is greater than 2000 or not. What if in the place of customer name, I just write sales? So now I'm writing that create an on-fly table of sales and then apply the filter of average sales, which is greater than 2000. Let's see what happens. Yes, so from customer name, it changed to sales because now we have created an on-fly table with only one column, which is sales, not customer name, right? Now, if I just click on this filter, you see, it has removed all those sales, which is less than 2000, because that's what filter we applied, right? We wanted to see the sales greater than 2000, so it has that, correct? But of course, if you want to present, you would like to see those customer name, which whose average sales is greater than 2000, which means this is working fine, correct? So we are done with that. So we have already seen how do we apply filter on a physical table, and then we have also seen how do we create an on-fly table and then we apply filter on that. But so now my question is, what if you do not want to return a table? In this case, you want to see that, okay, I have this shipped orders ready. Now I just want to see what is the maximum amount of order shipped. I do not want to see the whole table. Just let me know the maximum amount that we have shipped till now. What are we supposed to do then? Now in this requirement, you're not wanting a final table. You don't want that, right? What do you want? You want one value. You want one value, which is the maximum amount. That's what you want to see. So in this case, you're not going to use only filter. You're going to wrap it up with something called MAXX function. Okay, let's do that. So, and you are not going to create a table. This time you're going to create a measure because the result is one value. So new measure, or let's say MAXX sales. Okay. Now let's first create that table, which is nothing but auto sales data. And what do we want? We want status should be equal to shipped. This is giving me what? This is giving me a table with all shipped orders. But do we want that? No, we don't want that. We want to wrap it up. So we're just going to write MAXX and MAXX. If you'll see the syntax of the MAXX, first it asks for the table. So now because this first argument is creating an on-fly table which has all shipped orders. Now what is the next argument of MAXX? The next argument is expression. What do we actually want? We want the maximum of sales, right? So it's asking me to give me the column or the expression that you want to calculate the maximum of. So what are we supposed to give? We're supposed to give the sales, okay? And then that's it. So now what's happening here? With the help of this filter, we are creating an on-fly table which will only have shipped orders, and then we are giving the column that we want to know the maximum of this column, and then we commit. Let's see what happens. If I just pull a KPI card and if I just pull this maximum sales, it gives me 12.54. which means this is the maximum amount of order that we have shipped till now. So this was one example of wrapping filter function inside MAXX function, right? Where you calculated the maximum of shipped orders. You can also wrap it inside calculate function. What if you do not want to, you just don't want to see the maximum of shipped orders. You want to sum the sales. Whatever orders are shipped, you want to see how much order we have shipped, right? So you just want to sum the sales and you want to see that. How are you supposed to do? You are supposed to wrap it up inside calculate function. So for that, let's first create a measure called total sales. Because remember, the first argument of calculate was expression, correct? So what we'll do, sum sales, commit. Okay, I think we already have it. I'll just get total sales 1. So yes, we have total sales 1 measure created. Now, what are we supposed to do? We'll write total shipped sales. Now, calculate. For the first one is expression. What do we want to calculate? Total sales. I just created this total sales 1. So we are writing that we want total sales, but not for the whole data. Now we are going to give the context to this total sales, that in which context do we want the total sales. So, which means we are going to give it a filter, right? So in filter, we are going to create the table, the new table, which will have auto sales data, and the status should be equal to shipped. We have closed filter, we'll close calculate, commit. So what have we done? First, we are giving calculate the expression. That's what the first argument of the calculate, which is expression. So we are giving that we want to calculate the total sales, that is for sure. But total sales of what? Total sales of shipped orders. So this on-fly table will give a context to this measure that we want to calculate shipped orders, and inside that we want to calculate the total sales. That's what it's giving, right? So now let's just pull a KPI and total shipped sales, right? So now what is it? 9.02 million. Not just 9. Remember, we created a table called shipped order which only had shipped sales, right? If we sum the sale of this table that we created, it should match with this, right? If logically you think, shipped order that we created and the sales that we have, if we sum the sale of shipped order, it should give me the shipped order, the total worth of shipped order, right? And that's what we are doing here as well. We are calculating the total sales of shipped orders. So let's create the measure and check whether our calculation is right or not. So let's just test 1 and sum of what? Sales, but from which table? From shipped orders table. That's it. Pull a KPI card and test 1. And this is exactly matching with this, which means our measure is working perfectly fine. The measure in which we wrapped filter with calculate, that is also working perfectly fine. So this is how small tests you can perform to see whether your measure is fine or not. So yes, this was it. I hope you found it useful. I hope you understood what is filter function, how does it work, what does it return, what is physical table, what is on-fly table, and how we can wrap filter function with other functions. I hope all these concepts are clear, but of course, build conditions in your mind and try to write as many formula as you can. I'll pin this auto sales data in my description, and you just need to download it from there. You'll not have editor access or commenter access. All you need to do is just download the data set and try to write as many formula as you can. You can just imagine situations and you can write the formula. You can even use the ChatGPT to give you questions with this data set, and I want to practice filter function. You can give these kinds of prompts and you can generate the questions and practice from there. So yes, this was it for today's video, and we'll meet in next video with a new formula. Bye bye.